Well, I would like to take these exercises a little bit step further and by calculating the gradient of these graphs, of these functions. So, going back to the original examples, to find the gradients, let's say for the first one, for instance, fx equals to 4x squared at x equals to minus 2. So what we do first, if you face these kind of questions, is you take the derivative first, differentiate it. So in this case, as we did 4x squared, if we differentiate it, we take 1 from the power and then times it with the original power with the coefficient, subtract 1 from the power, and we get 8x, like in this case. But it's actually simple. But I like to add that, just to add a little bit more understanding to it, application. So after we find the derivative of 4x squared, so derivative, we can literally call it dy dx or df dx. It depends on what do you have on this side, in this case fx. So you might get a y or anything else, but usually it's fx or y. So df dx equals to the differentiation of the original graph equation, and then at x equals to minus 2, we literally just substitute x with the value we've got here. So it's going to be 8x and x equals minus 2. That means 8 times minus 2, which is going to be 16. It's very simple actually, but I like to add that so we have a little bit more understanding of it in applications and finding the gradients and that, because you might face that in the future. Anyway, let's do this for the second example as well. We've got fx equals to 2x cubed, or 2x to the power 3. Again, we take differentiation, so it's going to be 3 times 2, which is 6. It's going to be dy dx or df dx anyway, but I didn't write it because we don't have space. So we take 1 from the power and we're left out with 6x squared. Now the gradient is going to be, he says the gradient at x equals to 2, so we substitute x with 2, so it's going to be 6 times 2 squared. 2 squared, we know that it's 4, so 4 times x is 24. So that's the gradient. The second one. Again, let's try to do the other two examples. 7x plus 3. We took the derivative here, we found out 7. That's the derivative. So df dx equals to 7. And now it says at x equals to minus 5. Well, we don't have x here anyway, so there's no x, so it's going to stay the same. It's going to be 7. So there's no x, because there's no x is literally saying like 7 plus 0, because we ain't got x. Well, here in that fraction, well, we solved that fraction 1 over x. We changed the form of it, minus 1, we subtracted 1, we ended up with minus x to the power minus 1, or in this form, either way. He says find the gradient at x equals to half, so we take the derivative, we substitute it with half, substitute x with half. So let's try this one because it's much easier in this form, the fraction form. After we took the derivative, we ends up with minus 1 over x squared, so we substitute x with half, so it's going to be half squared, and we know that half squared is 1 over 4. So it's going to be minus 1 over 4, and you know, in the denominator, if there's the denominator of the denominator is in the numerator, so to get rid of the fraction in the denominator, we multiply with 4. So in both a numerator and denominator, so it's going to be equals to minus 4, and that's the final answer for the last one. So if it looks a little bit messy, just running out of space. But the last one is going to be minus 4. So what you literally do is just take the differentiation first. If he tells you, look, find the derivative and then find the gradient, what you do is differentiate first the equations first, and then after you differentiate it, you substitute the values of x, whatever he gives you in the question, and that's it.